Okay, so in this lab, I will show you how to take apart a motor for an oil burner and how to find information and how to diagnose some of the common major problems. So the first part you want to look at when you look at the motor is the information. So this is very important to record first, which is the model number, so you can call for part and see what would be the problem with that motor. Mostly all motors in oil burners are 3,450 RPM. So if you will replace that motor, you have to have the same RPM. This motor says it's thermally protected. That means that there is a switch here that will protect against overheat. If this motor draws a lot of heat, this will pop. So if you go to a job and you find this button popped, you want to go back. Don't just push it and start again. You have to go and look and see why did it pop. So why would the motor draw too much heat or make too much heat? Probably there's something wrong with it. Could be stuck, could be a bearing, could be over voltage. And all these does happen. So there's rotation is another important thing. Is CW. What is CW?
Clockwise.
Clockwise. So this is how it's installed, and this is the installation type, and the drawing FL means full load. So if it's loaded, it should be around 2.5. And what else? They used to put the safety factor here. That's a manufacturing thing. Code V, type SS. That's the type of the motor. Hertz is 60, so it's supposed to operate at 60 hertz. And we have one phase voltage, and this is the operating temperature, 40 degrees. So 40, you should be able to touch it. It should be warm, but it should not be too hot. If the motor is hot or making a lot of noise, it's time to investigate. So I took the burner out. The burner has been out of oil. I'm going to try to check and see the operation. You go with alligator clips and you turn it on. Right off the bat, you see some kind of rattling noise. Probably something is not connected correctly. Could be the coupling, could be the fan. So we'll move on and look inside the motor. So if you look in here, the first thing you want to do, you can try to rotate this by hand. See how it's wobbling, not in place? So something is wrong, and that probably is the coupling. So you try to rotate it by hand after you unplug it, and something is wobbling. And it could be also this over here. And inside you will also see the coupling which connects the motor to the oil pump. So I will try now to take out the motor. It's a very simple operation. You take out those discs. It's also important to mark where you took it so you don't install it the wrong way. So you want to open that up. So this has been very loose because we've been using this before. Okay, easy. You pull it out, and here is your coupling. So this is the coupling which connects the motor to the pump, and this is how the coupling. So this coupling is broken. So this is simple. It shouldn't be this way. So probably you have to change the coupling. You can see how it's broken over here. So this is a simple change of changing the coupling. So okay, we realize that it's a coupling. How do you remove this inducer fan? If you look here, the manufacturer, some of them actually, they leave an opening here so you can insert an Allen key and take out the inducer fan. See this coupling? It's over here. So you'll go with the Allen key and take out the fan. You have a set of Allen keys here. Okay. So you go from here outside. If it's stuck in there, or if it hasn't been used for a while, it might be a little bit challenging. So this is a little bit too big. I have to go a little closer. Okay, this is it. You just have to loosen it a little bit, and it will come out right away. It is loose. I have to take the coupling out. I think the coupling should be a simple pull. If it is, there you go. Make sure you wear gloves. These things are sharp. Take it out, and voila. Now we have the motor by itself. One way to inspect the motor is like look for burnt or burnt smell. It should, if you smell something burnt, you know, one of those, the tar over here, it has been burnt. This seems to be fairly smooth, working fine. You can listen also to the coupling. Seems okay with actually the bearing. And Nick was telling me also that if you can listen to the bearing by bringing a screwdriver or with wood and put it close to it, so you can listen to the grinding of those little balls in the bearing. So I'm going to try to turn it on here, and can you please grab me a clip-on meter? So one way also to test the motor. So this is loose now. It's going to have a lot of torque. What is torque?
Torque is what happens when the wind-up starts the motor, and
Yeah.
it's that.
How would you define that?
It's hard to describe.
It's actually what you do with your hand. It's the twisting force.
Yeah.
It is the twisting force of the motor and the torque.
You're giving
So-
it torque.
Yeah. So I will take this as the torque. It has also torque, so I have to hold it, and I will turn it on into the amperage. And this says it's supposed to be around 2.5 amps for full load. That's with the squirrel cage fan, inducer fan, and with the pumping oil. So I'm expecting something around 2.1 amps. I clip it on. I'm going to hold it, and I should be able to see the amperage draw. So this is drawing 2.23, pretty reasonable. 2.5 probably if I put in the pump, and the inducer fan should be good. Also listen to the humming. I'm gonna put it sideways, so we confirmed the amperage. I'm gonna put it sideways and try to listen to the way it hums. I mean, it seems a little bit normal, but if you feel there's some vibration to it, that is not okay. There should not be some vibration. So if you find vibration, I can feel that and hear it. It's humming. That means the motor is a little bit off alignment. Probably it hasn't been put together the same way, or something is not really correct with the setting. So eventually this will be okay for a while, but eventually it will develop some heat, or the bearing will go bad. Okay? What did you just hear? The clicking.
The centrifugal switch.
Yeah, centrifugal switch. So listen to it. It's gonna speed up the motor. Then it shuts it off. Then as you turn it off, it will shut off. If it didn't shut off, then this will spin and overheat and draw more amperage. So that's if you draw too much amperage. Bless you. What happens if you draw too little amperage? What if I put it in now and there's nothing? Like no, if it's drawing only 1 amp. Something wrong with the winding. Something wrong with the winding. So you can also check winding for continuity. It's going to give you the primary winding of the motor. You put the lead on it, it should give you the continuity and to check the amperage. Usually you'll find a lot of information here about this motor. I'll put it back, but I want to show you also this, another type of a common type of motors. This is a motor, it's much smaller, it does the same amperage. The information is almost faded here, so it's been used for a long time. And this has 1.8 amps drawing, and it's also thermally protected, it has the information on it. I'm going to try to start this motor and see what happens. So this motor has a capacitor. This capacitor is supposed to assist with the startup. So let's see how it works or how does it connect. And again, be careful because I'm going to try to draw this. It's a little bit wobbly as well, so I'm going to check this out. It's far away. Hold it. See how it's humming, but not turning. What is that? Remember the sketch I put on the board? When the capacitor is not engaging the startup winding, so the startup winding is not working. So in this case, 9 out of 10 times it is the capacitor is bad or it's not doing the function, it's outside, you can take it and change it. I want to do something also interesting just to show you what could help. If I turn that on, it seized completely. It's trying to turn, but it's not turning. So, meaning the magnets of the rotor and the stator are in the same place, and it's holding completely. So in this case, we'll change the rotor. We can try to take it out and also adjust that. Also, mind the gap between the inducer fan and see this. There's a hole here specialized for this, so you can put it in and open and kind of replace. So this is moving freely, seems fine. And when you put it back, do not put it too close or too far. That will affect the operation as well. And yeah, so in this case, we have to change the capacitor and it should run right away. Yeah, so what I want you to do is grab a motor and try to test for all these kind of abnormalities and see if it works or not. And usually you will find the RPM for that motor, the model, and you can change the motor with something similar. All right, good.